Hello, everybody. Welcome to our Ask SimScale question session number 5. I'm Edoardo.
My name is Johannes.
Yeah, so I'll quickly introduce myself. I'm a machine engineer here at SimScale since 2018, early 2018. This is my first job after university. I've graduated in 2017 in aerospace engineer in Italy. My favorite things about SimScale, it's always interesting to know that. Two things, actually. The first thing is there are people from everywhere around the world here, which is really cool. And the second is the fact that I got to move around quite a bit in different departments during this 1.5 years. And this gave me the chance to know better and, SimScale itself and, have a global view of it. So it's really cool.
My name is Johannes. I'm one of SimScale's co-founders. My background is mechanical engineering, which I studied here in Munich at the Technical University. My main subjects were all related to renewable energies. So I dealt a lot with wind power, water power, and these things. And then that naturally brings you into simulation, because without simulation, you can't really do much there. And then almost a little fun fact, almost to the day. So in 2 days, SimScale will have its 7th anniversary. So about 7 years ago, I co-founded SimScale with 4 other great guys. I'm really happy to see how the company turned out. My favorite thing about SimScale is definitely the team. I'm really amazed by the team, the people who work here, the atmosphere around the office. It's really great working with all of them every day, and I really enjoy coming here. And obviously, my second favorite thing about SimScale is Edoardo's lasagna, which tastes really good, by the way.
Sometimes. Cool. Then we will crack on. The idea is we'll start answering some questions from social media first. Then we will move through your live questions in the comments. So we got the first question from Twitter by Simon, who says, I saw you guys release something new for wind comfort. Can you explain what it does?
Mind if I take this one?
Yeah, sure.
So that's a very interesting question. We have not so long ago, I think it was just about 2 weeks ago, released a shiny new feature for something called Pedestrian wind comfort. And let me maybe just give a little introduction of what that does. So a very common problem in architecture is when you make a new building, a high-rise building somewhere in the city, typically, you have to make sure that under all the wind conditions that are expected at the specific location, the surroundings stay safe for pedestrians and also comfortable in case you have, let's say, an outside sitting area for a restaurant. So classically, those things were solved with wind tunnels. And as you can imagine, that is quite cumbersome. You have to make a scaled model of the city. You have to put your building in there. You have to make a lot of measurements. You have to install all kinds of sensors to measure flow velocities, pressures, and all that. And then the extra complication is that typically wind doesn't always blow at the same strength, and it doesn't always come from the same direction. So you have to do that with multiple directions, and basically you have to do a lot of different measurements there as well. And then at the end of the day, you have to take those results and then put them together into one useful picture, which gives you the answer. So we said, okay, now this is a great area to put a simulation in, and that's what we built. It's called Pedestrian Wind Comfort Simulation, and it basically allows you to run the whole process in the SimScale workbench, in the browser, and in just a couple of clicks. So I've seen a blog post on our website where we have a video, by the way, that demonstrates how to set up such a simulation, and it takes only about 1 minute. And this is a great time reduction. I think, I've heard about some engineers who said that it used to take them weeks to do that stuff manually. So it is now there. It's been released. We have been testing this feature very, very intensely for the last couple of weeks and months. And the first feedback which we have is really promising. The feature is not available, maybe I should mention that as well, is not available in the free version of SimScale, which exists. So that is because the simulations themselves are actually a bit costly for us. The simulation is running on GPU hardware, which is more expensive than normal CPU-based hardware. That's why it's sort of a bit of a pro feature, which we can basically unlock upon request if anybody of you wants to try it out. And so that is basically the new feature. The result will be a two-dimensional plot, so basically like a picture which has colors on it, and that is going to be according to the criteria, the pedestrian wind comfort criteria by Lawson and Davenport. Yeah, I'm really happy about this. Maybe I'm quite sure that everybody at SimScale has heard about this feature, and it's been a big thing. So we're really happy to have this out the door.
Mm-hmm. Yeah, I guess that answers the question. Okay, next one from Facebook by Adam. How can I know if a mesh is good? Okay.
Sounds like it's one for you.
Yeah, that's one for me. Yeah. Okay, good question. Well, there are different parameters that determine the quality of a mesh. It all depends on the shape of the elements of the mesh, so basically, imagine that a mesh can be made of out of hexaeders, for example, which are basically ideally cubes, and elements in the mesh can be very far from the cube if the quality is bad. So instead of a cube, you have a really flat element, and next to it you have another really flat element, which has another orientation. That the mesh quality is not good. You can check this in the meshing log of every mesh we run on our platform, and this is at the end of it. And this gives you an idea of the mesh quality. So there are 3 or 4 main parameters you can check, and usually when they are closer to 1, they are better. When you see big numbers in the meshing log, they are not good. That's basically it.
Do you have a good let's say guideline for where a mesh is, like when is a mesh too bad for a simulation?
Yeah, so if you take the aspect ratio, for example, aspect ratio is the ratio of it's defined in many different ways depending on the type of elements on the mesh itself, but it's the ratio of surface to volume roughly. So the closer to 1, the better, and a good mesh which doesn't give any problem in simulations, it must usually be below 100, 200, something like this.
And let's say, if a user has a bad mesh, he sees that, my mesh is bad. What can he actually do to fix that?
Yeah, so that could be the first thing I would check is the model itself. Usually you get bad elements when the model is dirty. So there are faces which you don't really want because they've been done by mistake. So there are small faces which are completely irrelevant to the simulation and to the model itself, and the mesh is bad in these areas. So I would check for the model first.
Yeah. Okay. We can see that there's a couple of questions popping in. The first one comes from Tina, and she's asking, how can you find the coordinates of the center of a wheel in SimScale for a rotating mesh? I can take this one up. So basically, generally when you make a model, then the coordinates that you have in SimScale and the coordinates that you have in your CAD are the same. So if you know the center of your wheel in your CAD tool, then the coordinates will be exactly the same on SimScale. So that is one way. Now, if you, for some reason, if you have to find it out, if you have to, if for some reason you don't know where exactly the point is, there's a little trick which might be helpful. You can create a so-called geometry primitive. There's a point, basically, which you can put there, and then you can see that in the viewer. And then you can basically move the point around by setting the coordinates until you have it. That's a trick which can help in case you for some reason the coordinates, the actual real coordinates, are unknown. But in general, let's say if you know the location in the CAD, then it's going to be the same in SimScale. Okay, I see there's another question popping in. Let's look at it. So there is there's the first one. I'm just going to read it out loud and then we can try to answer that one. It's from Julio, and he's asking, I've seen you guys have focused on post-processing development. What about numerical schemes, for example, DRP schemes or any high-fidelity numerical scheme? So this is a very good question. So, I mean, post-processing it has been a very big area of research and investment for us as well. I mean, if you've been a SimScale user for a longer time, you might still remember that the post-processor that we have is now much better than its previous one. It's much faster. It loads faster. It's much more interactive. You can do a lot more. So that's true. So we're actually quite proud of that. Regarding the numerical schemes, we have a bit of a philosophy of trying to simplify things rather than making them more complex. So whenever we, for example, put out a new setting somewhere in the user interface, it happens that people are not very happy about this because it makes, it increases the complexity of the UI. It takes a lot of space up, and sometimes people, are struggling to understand how it really works. So rather than focusing on adding more numerical schemes, we're actually trying to go the opposite way, and we will try to simplify this somewhat in the background. But to be honest, and there I do give you a very good point here, because like when you're deep into simulation, you know that at some point you just have to be able to deal with a certain certain details in the simulation. It's also very hard to automate everything. So probably this is going to end up in let's say in a split UI where you can basically have a simplified mode where people don't have to bother, and another mode where people can just, if they really want to, use the advanced settings. Okay, let's move on. He had a second question. I think that's also a very good one. So he asked about the scale up for massive runs.
Yes.
If you have, I've seen runs until 100 processors, but how does it behave with 500 or 1,000 processors? It's a good question. Yeah. I would like to just say a few things about parallelization.
Yeah.
So when you parallelize a simulation, there is a certain point beyond which it doesn't make sense, and that depends a lot on the size of the mesh size. Exactly. So the finer the mesh, the better you can scale a simulation up on many processors. So typically there's an upper limit beyond which it doesn't really make a lot of sense anymore. So for example, sometimes I see simulations that were run on, let's say, 96 processors, but the mesh is actually too small for being run on 96 processors. And then you will find that instead of speeding up the simulation, it actually slows it down. So in generally speaking, I would recommend something like maybe 100,000 to, let's say, maybe 250,000 cells per processor. And if you stick that rule, you should be somewhere in the sweet spot, for maximum performance. But it depends. Okay.
Switch to another guy because
let's check this one. There's another one, another question from Facebook, which we've seen.
Right.
From Jacob.
Yes. So what are the main things that can make a simulation crash? Yeah. First, I would say in order of logical order is the mesh. As we just spoke about mesh quality, right? If the mesh is not good, the cells have high aspect ratios, as I said before, then the simulation may crash. If the mesh is good, then we need to look at the simulation setup. Boundary conditions could be the cause of the failure. For example, the boundary conditions don't really make sense, and like you have one inlet and no outlet, for example. This is just a basic thing. This for sure will lead to a simulation to fail. Then there are numerical schemes which can be unstable by nature, and if this is the case, then they can lead to instabilities and make the simulation diverge. This happens for high-order schemes, for example. Johannes was talking about it before. High-order schemes are unstable, and this may lead to instabilities in some cases.
Yeah. If, for example, if you find that your simulation is too unstable, switching to upwind schemes can help.
Yeah.
And yeah, we are trying to figure out a good way for, again, automating this a little bit better, so you don't have to, like fix it after the fact, only after you know that it has actually diverged. Yeah. We try to be a bit more proactive here and fix that before you actually run something. But it can help. So I find this is a pretty good, it can be a pretty good lifesaver sometimes if you have a mesh that, is not as good as it should, and it's hard to make it much better. Then sometimes these numerical schemes can really help a great deal. Okay, let's see, what else do we have? There's one question from Virengos. He asks, is it possible to export a CFD setup outside of the SimScale platform to investigate it on my local machine, for example, the boundary condition files or the solver files? That's not possible, unfortunately. So this is a feature which we just don't have. However, I mean, if you, let's say, if there's a very, if you really need to know, you can always approach our support, and we can actually try to, to give you access to those files or provide some more details. But so basically, it's not, we don't have a download button or anything where you can just export the CFD files. However, in the backend, of course, those files need to exist. So this is all somewhere. Sometimes, for example, people ask us, okay, if I set that kind of boundary condition, how is it actually implemented? For example, we have a boundary condition in CFD, which is called pressure outlet. And the UI doesn't really give away how it works in the background. Sometimes you can find this out by looking at the documentation. So sometimes in certain areas, we have a very detailed explanation how these things work behind the scenes in there. But if it's, let's say, something that is more advanced, then you can always approach us, and we're going to help you. There's also another thing I would like to say about this. So we have, especially in CFD, maybe some of you guys have already discovered it. We have a so-called custom boundary condition, which allows you to basically set the boundary condition up like it would be in OpenFOAM, for example. And so that gives you really access to all the details. So let's say if you have to have a specific setup and a specific combination of boundary conditions, then you can switch to custom and then just use that. For those of you who are more experienced in CFD, that can definitely be a good alternative and can sometimes be very, very helpful. Okay, there's another question. Maybe this one is a good one.
So what is the difference between conjugated and convective heat transfer? Yeah. So the first one, conjugated heat transfer, is a simulation of solids and fluids altogether. So the model of such a simulation will be will have solid parts and fluid parts. For example, a really good example is a case of a computer, of a server. So you have all the CPUs, the PCB boards, and so on, all the solid parts that produce heat, the heat sinks, the fans, whatever, and the air around them. So what you simulate is the heat transfer and heat production in the solids and how the heat is dissipated with the air flowing around them. That's it. While convective heat transfer is only a simulation of a fluid region. So you have only the fluid domain, so one region only, fluid region in which air or whatever fluid you're simulating moves, and you're taking into account temperature changes, density changes, and so on. So you could see conjugate heat transfer as a convective heat transfer simulation plus the simulation of the heat transfer in the solids close to the fluid region.
Yeah. Is there anything that a user needs to pay attention to in his model, for example, when he wants to choose either simulation?
Yeah, absolutely. So the main thing is in conjugate heat transfer. So as I said, the model needs to have solids and fluids as separate regions. And what's very important is that when you import the model for a conjugate heat transfer simulation, the model needs to be imprinted, which is imprinting is a geometry operation we need to do before anything else that imprints, guess what, the solid faces into the fluid region. So the solver knows that one face of the solid is touching with the adjacent face of the fluid, and heat transfer happens in this interface. So this is really important.
Mm-hmm.
Yeah.
Okay. There was another question. I'll take this one because this is one of my favorite onboarding questions as well. Daniel is asking us, can you explain in short, why is it at all required to mesh in order to run a simulation? So this is a very good question, indeed, and it's certainly not trivial. You know, the answer doesn't just fall from the sky. Yeah. So in a nutshell, when you deal with simulation, it has a lot to do with mathematics and physics, right? So you put together equations, and those equations have been known for a long time already, for hundreds of years. And those equations are usually, there are two, which you take into account, at least for CFD. For solid mechanics, it's slightly different. For CFD, you look at the conservation of mass and the conservation of momentum, typically. Mm-hmm. And so writing them down is fairly straightforward, but what is not straightforward is solving them. So in fact, there exists no known, no textbook way solution. Correct me if I'm wrong. I don't think this has changed, and I would also bet money that it doesn't change anytime soon. Yeah. So there is no easy way to just solve them once and for all. So you have to be very creative in like finding a solution, because at the end of the day, you're interested in a solution to your technical problem. Mm-hmm. So what engineers have invented is basically a way to solve them using, I always call it brute force. Okay, so you don't have a good analytic solution, fine. So let's try to give it at least an approximate numeric solution, and that is done using the mesh. So that has to be done by taking the model. Okay, and each model is unique. Each shape of each part is always different. You're never going to see the same part twice, or it's going to happen very rarely. So you need to take that model and you need to break it up into little subparts, which are so small, and that is the point, so small that you can assume that certain quantities inside of such a small piece are constant. And those small parts are essentially then what we call the mesh. And then once you have a mesh, the solver will take the mesh, which basically has information about how these little elements are connected and also where the boundaries of it are. Mm-hmm. And then, as most of you guys know already, on the boundaries where basically the part interacts with its environment, the environment is cut away, let's say, from the simulation. Where it interacts with the environment, you need the boundary conditions. And then inside of the mesh, the solver knows which elements are touching where. And so, for example, it knows when a certain amount of mass leaves one element and travels into the neighboring one through a face. It knows that, and then it basically can put together all those equations in a discrete form and then solve it. Yeah. And that's in a way, or in a nutshell, how simulation works. There are ways, maybe I should mention this as well, where you do not need a mesh though. And one of those is, for example, the pedestrian wind comfort that I mentioned earlier. That is based on a method called lattice-Boltzmann, which is based on a very interesting theory actually called statistical mechanics, and this one does not require any mesh, and that's a big advantage because you save some time for the meshing, you also save some problems, but also then there are pros and cons, right? Not, for example, lattice-Boltzmann cannot deal with every kind of physics in a very good way. So sometimes you have methods which just require mesh.
Yeah, I think there's still an award for whoever solves the Navier-Stokes equation analytically.
Pretty sure
it's a big one also, but nobody manages.
I would chip in on that one. I'm quite sure that this is not going to happen
anytime soon. Yeah,
anytime
if
soon.
ever. Yeah, if ever. I have no idea.
Yeah.
So I guess we can wrap it up with.
There's a question from Sohail.
Yeah.
Please allow hobbyist and single student free license for learning purpose. It would help a lot. Good news here. This is actually there already. Exactly. So when you sign up for SimScale, you can apply for a student license for academic purposes. and then you can use SimScale free of charge. You will get you will basically get access to almost all features, not the ones that are, let's say, really expensive on our side, like pedestrian wind comfort, for example, but you get basically access to most of it, and you can use SimScale free of charge. And as a matter of fact, we have a lot of students around the world already using it. For example, we have quite a few Formula student teams who are simulating their race cars and their race car designs. And that is something which I'm really fond of and which is very exciting. That it's really great to watch, so many smart people, the engineers of tomorrow, basically using SimScale for improving their designs and for testing them in a virtual environment. This is really great stuff, and we want to encourage you. We want to make sure that all engineering students in the world have access to simulation without any problems. And we know that the budget of the typical student is rather thin, so we pay respect to that. And so please go ahead and sign up for an academic account, and you will have access to SimScale and without any problems. Okay, maybe I think we have time for another one.
Yeah, I think so, yeah.
Before we have to wrap this up.
This is from a live question from YouTube, Valdi, or Waldi if it's British, I don't know. So I also have another question. He says, the machine looks new and is now called standard mesher. Word change, of course, yeah. So in the past, we had only 2 types of meshing, yeah. One was TED dominant based, and the other one was hex. And now we have a new one, which is a hybrid one, and it's very different from the others. It is faster, first of all, and it combines both TED elements and hex elements. It's working really good. So we just shipped it basically to everybody. We shipped it a few months ago, and now is the default mesher for everybody. So whenever you run also just a tutorial case, you will use this mesher. This will save you basically half of the time with respect to the old meshes. And yeah, it's really good.
Maybe one feature we could also highlight at this point is the small feature suppression.
Yes, right. Yeah, I was talking about the small features in the CAD you really don't want because they decrease mesh quality. The new mesher has this feature, which is small feature suppression. And basically, you simply set a tolerance, which is the size of the features you don't want in the mesh. And the mesher suppresses them. So they are removed from the model, and then the model is meshed. So this is really cool. Yeah.
Okay, there's another quick one, I think, but also a very good question. Is SimScale restricted to location? I reside in Nigeria and would love to learn simulation. So good news here as well. No, it's not restricted. Basically, SimScale is available through the internet everywhere in the world. It may depend a little bit on your, on the internet situation in your location. So, for example, sometimes we see that certain firewalls exist which block access to, let's say, to certain ports, which may be required, and so forth. So this is the exception, but this is also something against which we cannot really do much. But let's say if we take all of that out, then in principle, SimScale is available everywhere. And I'm really happy to hear that you would love to learn simulation. I can only encourage you to do this because it's, I would say, it's one of the best occupations in the world and one of the most interesting things to deal with. So please go ahead, just give it a try. If it doesn't work, let us know. That's a general thing which I would like to put out there as well. Yeah. Whenever things don't work for you, please inform us. We will take it up. We will try to fix it and do as much as we can to make sure that SimScale is and stays available to everybody in the entire world.
Yeah, exactly. For any other question, I think we have to wrap it up now. If you have any other questions or you have doubts about anything, you can write in our forum, and people will happily answer to any of your doubts.
Yeah, that's it. The recording of this video will be live, so this is going to be there for you to watch again. Yeah. Thanks for watching it. It was really great to have your live questions here. Thanks for all the questions, by the way. It was really great. And see you again next time.